Hello students, I am here with another video related with the chapter Electricity of class 10th. Before starting today's video, I would like to discuss that so far we have studied about electric charge, current, potential difference, potential, and even some numericals related with potential difference and current. In the last video, I have discussed about Ohm's law. Now today we are going to discuss about resistance of a conductor. Now why we are discussing this resistance? Because in the last slide, in the last video, we have discussed about Ohm's law. That Ohm's law, by seeing that Ohm's law, we understood that resistance is equal to potential difference upon the current supplied. Now that word resistance was introduced first time from Ohm's law. Okay, so we are going to discuss what is this resistance known as. Fine. So resistance is a property of a conductor due to which it opposes a flow of current through it. Okay, so it is a kind of a property of a conductor due to which it is opposing the flow of charges, because of which the charge cannot flow properly. So that property of resisting the current flow is known as resistance. Now resistance of a conductor is numerically equal to the ratio of potential difference across its ends to which a current is flowing through it. Okay, so that only I have written earlier, that resistance is the ratio of potential difference and the current flowing through it. Okay, so resistance is the ratio of potential difference which is divided by the current flowing through it. Fine. Now let's see the let us understand more about resistance through a diagram. Now here I am showing this diagram to show you the property of resistance. See here, this black surface which is drawn here is the surface of a metal, or surface of a, you can say it is a surface of a conductor. Fine. Conductor is made up of it is also made up of atoms. Okay, now what happens inside when the current is flowing through it? Okay, now here what is done, we can see that these blue dots are drawn and a black dot and some black dots are drawn. This black dots represent atoms of conductor, and this blue dot represents the free electrons or the charges which are flowing through them. Now when the flow of electrons takes place through this conductor, what happens? This free electrons faces some difficulty in flowing. Why difficulty in flowing? Because atoms of conductors are present in between the conductor. Fine. So because of which the free electrons are not easily moving through this conductor, so they are going to collide while moving, so their speed becomes slower. Now if more and more atoms of a conductor is present inside it, so what will happen? The free electrons are not easily moving. It means the current will be lesser. Fine. It means the resistance of phi, this is now this is called as the resistance of a conductor, because of which the property because of which the current is not able to flow properly inside any conductor. Okay, I hope you have understood now. So okay, now this property of resistance is helping the to draw the current which is flowing through any conductor. So, in some conductors a small amount of current could be flown, and in some conductors a large amount of current could be flown, because of which the property of resistance, it is of two types. The resistors are of two types. Okay, some are called fixed resistors and other ones are called the variable resistance, or in the symbol, when I was teaching you symbol, then I have told you about resistor, rheostat. This is a rheostat, which is also known as variable resistor, where you can see this plug, you can slide this plug so that the resistance could be increase or decrease. So on the basis of resistance, it is of two types: fixed resistors and variable resistors. Fixed resistors are those resistors whose value does not change in the physical condition. They have a set of particular values. You can see that these are very small, these are very tiny type of resistors which are present inside the circuit, but they have a strength to resist the flow of current. Okay, now variable resistance means their resistance could be easily changed by changing the area of cross section and length. Okay, now when we are moving this this switch, this resistance could be increased or decreased. Okay, now what is the unit of resistance? According to Ohm's law, the resistance is a ratio of potential difference with current. Okay, now what is the value SI unit of resistance? It is ohm. Fine, it is denoted by the symbol omega, which is written like this. It is a half circle. It is written like this, or simply you can write it as ohm in the spelling form. So this is the SI unit of resistance. Now let us understand more about ohm. Now what is 1 ohm? If the potential difference V is 1 volt and current I is 1 ampere, then resistance from the above equation, it becomes 1 ohm. Okay, in simple words you can say that 1 ohm means it when the potential difference is 1 volt and the current flowing through any conductor is 1 ampere. Both the variables, that is the potential difference and the current, is fixed to 1 volt and it is fixed to 1 ampere. So if the ratio of 1 volt to 1 ampere, that will become 1 ohm. Fine. 1 ohm of resistance of any conductor such that when a potential difference is 1 volt applied to its ends and the current flowing through it is the 1 ampere. So we should learn that resistance 1 ohm means it is a SI unit of resistance and it is equal to 1 volt per ampere. Fine. Now we should understand that what is the relation between the current and the potential difference. So when Ohm has performed the experiment, he saw that there is a direct relationship between potential difference and the current, and when he has drawn the graph, we can see that if the conductor is following the Ohm's law, if the charges are following Ohm's law, then we are going to get a straight line graph when we are going to plot it as between V and I. Then again, if non-ohmic resistors are there, where some conductors are said to be non-ohmic because they are not following Ohm's law. So these non-ohmic substances, if you are going to plot a graph, then it is not showing a straight line. So such substances will be termed as non-ohmic, and those who are following Ohm's law, they are said to be as ohmic conductors or ohmic substances, such as copper wire is there where electrons are flowing. Now let us recapitulate, let us understand, let us revise what we have studied today in today's video. We have studied the property of resistance. So it is defined as the hindrance to flow of current. It is a ratio of potential difference to current, okay, that R is equal to V upon I. Its SI unit is volt per ampere. Okay, we can say ohm in the other words as volt per ampere. Why volt per ampere? Because it is the ratio of potential difference versus current. So what is the unit of potential difference? It is volt. And what is the unit of current? It is ampere. So we can also say the SI unit of volt is SI unit of resistance is volt per ampere, or simply we can denote it by writing ohm or the symbol. Okay, now reciprocal of resistance is called conductance. We should not, I'll not enter inside this conductance because this concept will be it will be cleared when you will reach in class 12th. It is, you people will study about conductance in class 12th. Now this small diagram is showing you the high resistance and low resistance. Now whenever any conductor is offering high resistance, it means it is allowing a very less amount of current. Okay, so we have seen this in the diagram. If any conductor which is offering a high resistance will allow less number of electrons. Why less number of electrons? Because more and more atoms of conductors will be present inside, and less free electrons could move. If free electrons are less, it means it is going to decrease the amount of electricity. Okay, now in the next this diagram, we can see that it is offering low resistance and high current. Why low resistance is offering high current? It is very clear from the diagram again, that if these atoms of conductors are less, it means there are less hindrances present inside this conductor, and free electrons could easily pass through this conductor. If more and more electrons could pass through, it means it is going to increase the amount of electricity flowing through it. Okay, so this is how the resistance is related with the amount of current flowing through it. Now there are certain more factors which are affecting the resistance. We'll discuss it later on. That's all for today. Thank you.